we've looked at the basics of waves and wave characteristics, wave properties, and a little bit at sound as well. We're now going to have a look at light as a wave. First thing to make note about light, though, is that it's not a mechanical wave. So if you recall, mechanical waves need a medium to travel through. Light is not a mechanical wave, as it can travel through a vacuum. So there's no particles that it needs to travel through. It can travel through matter, so air and water, for example, but it doesn't require matter to travel. That's because it is an electromagnetic wave. And we'll have a look in a bit more detail in the next video at what that means and why that's important. It does exhibit a number of wave phenomena. And we'll have a quick look at some of those now, and we'll take one or two of them a step further in subsequent videos. So the first one is reflection. So reflection basically being that it will bounce back into the medium from which it travels. So light waves incident on a plane surface, or a plane reflective surface, I should say, they will bounce back. And if we sort of represent that diagrammatically, so if we have a say reflective surface here, I'll just put some marks on to represent the back of that reflective surface. As the light waves, so if we think of sort of the wave front of the light waves looking something like that, and keep in mind this is a diagram, so apologise if the lines aren't quite straight. So as the waves are travelling that way, we'll see those waves then reflect back out, and they will then be travelling back out that way. And so there's a very, very brief explanation of reflection. The second one then is refraction. And for refraction, what we see is that light waves bend and change direction as they travel from one medium to another. So when we're talking about a medium, we're talking about the substance through which light is travelling. So while it doesn't require a substance to travel through, it is affected by substances that it does travel through. So obviously through a vacuum it's going to travel fairly quickly. Through other substances it might not travel as quickly. If we look at this sort of scenario, if we had so medium 1 at the top here, so this might be something like air to water or air to glass, something along those lines. If we have the waves travelling down this way, when they start to enter the new medium, they're actually going to bend, and you'll notice in this representation, as well as bending, the wavelength is also going to change. So we'll go through refraction in a bit more detail in one of the coming videos, but you can see there that the direction of the wave was that way, and now it's a little bit, it's changed direction slightly, and you can sort of see that there is this bending of the wave at the boundary between the two media as well. The third phenomena is that of diffraction. Now diffraction, it's basically just the bending of a wave. Light waves. So light waves will bend when travelling through a narrow opening. And when we talk about a narrow opening, we're really talking about that opening being sort of comparable to the wavelength. So it's not just any opening that you could come across. We're talking about very narrow sort of slits or narrow openings. So in this case, if we imagine that we've got I'll just change colour here to make it a bit clearer where the opening is that we're dealing with. So if we had something that looks like that, where we've got this very narrow opening across the middle, as light waves are travelling along this way, what we'll see is that as the waves start to get up to this barrier, the waves through the middle here will then start to cause the light wave to bend and travel in a circular pattern instead. Now you can see there that initially the waves were all going in the same direction, and now they're sort of spreading out from that slit. Diffraction itself is something that you can spend a lot of time on. We don't need to for this course, but if you do go looking, you'll find quite a lot of information about diffraction and diffraction patterns, and why it's important to have a good understanding of what's happening with diffraction. The last one then is interference. Now interference, I'm going to state what it is, but I'm not going to bother trying to draw a diagram here. We'll have a look at this one in a little bit more detail in class. Again, we don't need to go into it in as much detail as we can, but there are a couple of explanations that are a little bit easier to show or to talk through. If we take two coherent sources of light, and so by coherent we basically mean they're in phase, they're doing the same thing at the same time, they will interfere constructively and destructively. And similar to standing waves in a sense, we see a pattern of bright and dark regions, and known as an interference pattern basically. So the really good example of this one is Young's double slit experiment, where basically showed that light does behave as a wave, and I'll just show you what that interference pattern looks like. So that image there is the interference pattern if you were to shine, say, a laser onto two parallel double slits, and you can see there that we get this these bright regions where the light is interfering and causing it to be visible, and then in between those regions we get these dark patches where the light waves are actually cancelling each other out. So you can think of the bright regions as being anti-nodal lines, so a large amplitude, and the dark regions as being nodal lines, so where the destructive interference occurs. As I said, we'll have a little bit of a look at that in class to explain how we get that interference pattern and why it is that constructive and destructive interference results in that sort of pattern.